Okay students, now we will discuss some kind of differentiation. First we will start with derivative of composite function. Okay, before discussing this, students, see here, suppose we have a function y is equal to fx. Here x is independent variable, y is dependent variable. So derivative of y with respect to x is denoted by dx of y. It is also called gradient in the language of physics or maths, you can say, or you can say dy dx represent slope of any curve at a given point. Okay, so just keep in your mind this thing. Okay, now come to derivative of a composite function. Students, see here, if we have more than two or more than two functions, and how we will differentiate that. Okay, so see here, if we have a function u of g of x, it means u is a function of x and another function y that is a function of u, then how we will find the derivative of y with respect to x? So very simple, student, here y is equal to dy upon, or you can say here differentiation of derivative of y with respect to x can be represented as, because y is depending on, see student here, y is depending on u and u is depending on x. So using chain rule, here we are using chain rule, means composite function by chain rule, you can say here we have to find derivative of y with respect to x. So first what we will do, we will find derivative of y with respect to u, because y is a function of u. Okay, multiplied by derivative of variable u with respect to x, because u is depending on x here. Okay, so in this way du will be cancelled out by du. Okay, then you will get dy upon dx, right? Similarly here, when any function is given as just like this, fx is equal to gx to the power n. This we have already studied in class 11th also. Here power is n may be 1, 2, 3, 4 or greater powers. So derivative of x is defined as or denoted as f dash x. Okay, or you can say dy by dx, that is equal to, according to the chain rule, power will goes to the front side, so this power comes here and 1 will be deducted from that original power, so n gx of n minus 1, and according to chain rule, this multiplied by again derivative of inner side function, that is gx, so that will be g dash x. Later in some examples we will discuss this. Now one more thing is there to be noted here, dy upon dx can be written as 1 upon dx upon dy, means dy upon dx is reciprocal of dx upon dy, provided dx upon dy must not be equal to 0. This implies that dy upon dx multiplied by its reciprocal dx upon dy is always equal to 1. Okay student, now come to the next derivative, that is derivative of absolute value function. You know student that absolute value is represented by mod of x or modulus of x, and modulus of x can be written as under root x square. Now if you want to differentiate y with respect to x, okay, how we will differentiate? So here y is equal to mod x means under root x square. So using the chain rule here, what we will do, actually the power of x square is half. This can be written as x square power half. So according to this formula, what we will do, we will take out this power ahead. So we will get here half, then we will get inside x square and half minus 1, and further derivative of x square, derivative of x square. Okay, now if we will solve this, then we will get here half. Here we will get student x square, 2 1 the 2 minus half, power will be minus half, it means we will get here 1 upon x square. Okay, and derivative of x square again, that will be 2x. Now 2 will be cancelled out by 2. Here we will get x upon under root x square, and this is nothing but this is x upon, and x square can be written as modulus of x. here mod x must not be equal to 0. It means we have a formula here, derivative of modulus function x is equal to x upon mod x, where mod x should not be equal to. This is a new formula for you have to keep in your mind. Okay, so we have discussed two functions here, derivative of two functions, derivative of composite function and derivative of absolute value function. Some question we will discuss again after this. Okay, thank you.